Welcome to the combined presentation of what's new in MDA 8.6.5 and 8.6.6. My name is Matthias Gekeler. At ETAS, I am the Product Manager for MDA. In the present video, I'm going to demonstrate the new features and improvements listed here. In the description below the video, you can find jump marks to access a topic directly. First, I will demonstrate a new possibility to handle configurations. Before MDA 8.6.4, it was possible to open the same configuration multiple times. But then it could also happen that the wrong variant of the configuration was saved. Thereby, the desired configuration could be lost. That is why one configuration can be opened only once since MDA 8.6.4. But there exist also use cases in which the same configuration shall be used multiple times. For example, when analyzing different measure files in parallel, you might want to have the same view on each of the measure files, but in independent configurations. To support this use case, a new configuration format was introduced with MDA 8.6.6. We call it a configuration template. You can simply save a configuration as template in the new XDT format. Such a template configuration can be opened multiple times. Accordingly, the desired use case is already fulfilled. Another advantage of a configuration template is that it can be opened faster. This is achieved by skipping the loading of the referenced measure files. There appear only placeholders of the original measure files. And eventually, instead of conducting multiple replace file operations, a simple adding of the desired new measure files is sufficient. The already existing dialog for adding or replacing measure files allows to assign the newly selected files as replacements for the placeholder entries. Whether you have opened an ordinary configuration or a configuration template makes no difference for the usage of MDA. The only aspect you have to keep in mind is that you can save changes in the configuration template only by saving again as template. Then you can also override an existing configuration template. When saving your work in the usual manner, an ordinary configuration with the file extension XDX is created. The file extension also allows to distinguish between configurations and configuration templates. The next topic is about a new instrument for displaying battery imbalance values. The battery system of an electric vehicle consists of a large number of battery cells. Often, for each cell the individual battery voltage can be recorded. Since MDA 8.6.3, a first battery instrument is offered. It allows to find the signals with the highest and the lowest voltage values. More precisely, it helps to identify the cells which have the largest positive or negative deviation from the mean of all cell voltages. This difference is called imbalance. With MDA 8.6.6, the new Imbalance Graph instrument can display the imbalance for many battery cells, whereby a good overview of the battery system is given. In the new graph instrument, each column represents the imbalance of one battery cell. The cell names define the order of the columns. The instrument can be synchronized in the usual manner, so you can use the oscilloscope to navigate to an interesting point in time. Then the imbalance graph shows the overview of all individual cell values for the same point in time. For an easier comparison, the lowest and the highest imbalance values are drawn as horizontal lines. The tooltip for each column reveals the precise imbalance value and the signal name. If a signal is removed from the instrument, it might happen that the horizontal orientation line for the imbalance minimum or maximum gets updated. The same happens if a new signal with a more extreme imbalance is added to the instrument. Here you can see again that the new signal is added at the position which corresponds to the signal name. In my example, the signal appears therefore again at position 23. Another specific functionality of the new instrument is that you can zoom and scroll the graphical view. Then less columns are visible but magnified. By double-clicking the end marker of the scroll bar, the view gets resetted to the whole overview. The following section is about improvements for MDA's calculation functions. In the first part, I will show some new predefined calculations. As you can see on the slide, the number of predefined calculations delivered with MDA is continuously increasing since version 8.6.4. Also, with future releases, some further calculations will be implemented. The way how to use predefined calculations has not changed. First, you create a new function instance. Preferably, you define for it a reasonable name. In the next step, you select the desired predefined calculation from the drop-down menu. The field below contains a short description for the selected calculation. The same information can be seen also in the tooltip for each of the entries in the function library. Next, you assign the needed input signals. In my example, this is just one input signal. And eventually, you save the function instance. Now the outputs are available in the Variable Explorer. You can find these by means of the function instance's name, which you defined formally. Alternatively, you can use the filter for calculated signals. The output signals can be used as ordinary measure signals. For example, you can assign these to instruments. In my case, the lines represent the absolute minimum and maximum of the input signal, which helps as orientation for the current signal value. The output signals of a function can also be used as inputs for calculated signals. In my example, I want to calculate the relative share of the current signal value to the maximum. In my second example for a predefined calculation, the number of input signals is not defined strictly. Let's assume your measure file includes the voltage values of the individual cells of a battery system. In the oscilloscope, you can display for all the individual signals their signal curves. But often, not the individual signal and its curve are interesting. Instead, just the envelope curve of all signals would be sufficient. With the respective predefined calculation, you can easily get for each point in time the minimum and maximum of all input signals. Both signals represent the envelope curve. Additionally, the average value is listed in the Variable Explorer. Instead of assigning all individual cell signals to the oscilloscope, just the calculated minimum and maximum outputs can be selected. This makes the representation clearer. But it still ensures that no extreme spikes get lost. And the envelope curve can still be used to navigate to interesting points in time of the battery voltage. My third example is about some special output signals. When an electric vehicle is connected to a charging station, the battery system and the charging station communicate by means of a so-called control pilot signal. The voltage value of the control pilot signal determines the state of the charging process. The duty cycle of the signal defines the maximum charging current. As you can see here, for the state of the charging process, also verbal output values are defined. These definitions in the standard are the basis for the two new predefined calculations named AC charging status and AC charging current. First, MDA has to determine the voltage level. The respective output is named Control Pilot Peak Level. Besides this numeric signal, all other outputs defined in the standard are available. These can have numeric or verbal output values. In the second part of this section, some enhancements for the usage of functions will be demonstrated. First, there is now the possibility to copy and paste a function instance so that you can quickly reuse an existing instance, for example with some other input signals. As you might know, besides the predefined calculations provided by ETAS, MDA also supports FMU models. This allows you to include your own calculations. Since MDA 8.6.5, an additional icon facilitates to use such FMU files. After selecting the file, it is copied by MDA into the folder from where MDA will read it. Since MDA 8.6.6, the newly added FMU file will appear automatically in the functions library. Additionally, a message in the status bar informs about the new entry. The difference to MDA 8.6.5 is that there the present configuration had to be closed and reopened to show the new entry in the functions library. And finally, function instances can be exchanged easily between configurations. It is sufficient to start an import of the configuration, which includes the desired function instances. In the import dialog, the available instances are listed and can be selected. The import dialog shows all function instances, namely those based on predefined calculations of MDA, as well as such which use an FMU model. However, to conduct the calculation based on an FMU model, the respective FMU file must be present. Optionally, you also need to copy the FMU file to the target system. In the following section, I will present some enhancements for the device mapping dialog. Since MDA 8.6.4, some checks are performed after measure file replacement. This is done to assign clearly the devices which are available in the new measure file to the devices which are referenced by the signals used in the configuration. Whenever the design assignment cannot be done unambiguously by MDA, the device mapping dialog appears. In the dialog, the entries listed on the left side represent the devices found in the new measure file. In the table on the right side, the column on the right lists all the devices referenced by the signals in the configuration. In the center of the dialog, the device assignment is done. As you can see in my example, MDA 8.6.6 tries to pre-map devices. This is done if the device information or if the ECU information can be mapped clearly. In my case, there is in the new measure file and in the configuration exactly one entry for which no ECU information is available. Therefore, these two entries are pre-mapped. The remaining entry of the new measure file can be mapped manually to the remaining entry on the right side. After confirming the assignment, MDA tries to replace all signals in the configuration by signals with the same name from the new measure file, whereby the ECU device assignments done in the mapping dialog will be respected strictly. In my example, this can be seen for the signal named cats. MDA could not find a matching signal with the corresponding ECU device combination. However, the measure file contains a signal with the same name. But this has another device information. As I assigned the device named Stuttgart to the device named Bangalore, MDA must not use a signal from another device for the replacement. Now, what should you do when the device mapping dialog appears? If typically all the signal names in your measure files are different, you should skip the manual device mapping, because this would cause that MDA must respect your assignment strictly. To demonstrate how you can skip the manual mapping, I use undo and start the file replacement again. But this time I activate the new option so that MDA can try to do an automatic mapping. Now, in most cases MDA can replace all signals which are available only once in both the new measure file and in the configuration. But there can be also some more complex cases. For example, if the configuration evolved over the time and signals were selected which have the same name but derive from different devices. Let's have a look at another example file. This will show the pre-mapping done by MDA more clearly. Here, both the new measure file as well as the configuration, contain signals which have as device information the term Stuttgart. Moreover, the ECU entries town and city are both unique. Therefore, MDA proposes the mapping City Stuttgart and Town Stuttgart. Again, this assignment will be respected strictly for the signal replacement. Accordingly, signals in no-match state can result. MDA checks already in the file replacement step whether all signals can be replaced even with a strict device mapping. If this is the case, the device mapping dialog will not be shown. But in reality, there might be often more complex cases. Then you need to decide whether you conduct the strict manual mapping or whether the signal names are unique and the automatic mapping is more reasonable. In my last example, the original measure file was recorded in MDF version 3 format. This format does not support ECU information. This causes that entries with null/device are listed. Moreover, my example shows one entry with the asterisk as ECU information for the device Mont Blanc. Such an entry results when originally an XDA file was imported. Also, the XDA file does not contain ECU information. To handle the limitation of the XDA format in a feasible manner, the asterisk is used as a placeholder. And one final comment about the device mapping dialog. Since MDA 8.6.5, the dialog includes a direct access to the online help. There you can find a description for the general usage of the dialog. Moreover, there is a reference to the explanation how MDA identifies signals clearly and from where the entries for ECU and device originate. For future versions of MDA, some further improvements around the file and signal replacement are planned. It is planned to suppress the device mapping dialog for some specific cases. And for signals in no-match state, the ECU and device information will be shown. The last topic in this presentation is about an enhancement for reading and writing ASCII-based measure files. The example and description file for textual measure file formats includes two new options. These can be used to define characters which shall be ignored when reading the file contents into MDA. To illustrate the behavior, I prepared a measure file. It has at the beginning of each line a euro symbol and at the end a dollar symbol. Accordingly, I adapted in the ini file the options start row character and end row character. MDA reads the textual ini files when the application is started. Afterwards, the corresponding measure files can be loaded and analyzed in MDA. In the Variable Explorer, it is visible that the currency symbols of my example file were ignored for the signal names. The table instrument shows that the same happens for the measure data. Finally, you can see here an overview of all the changes done in MDA 8.6.5 and MDA 8.6.6. For more details, please have a look into the What's New slides. You can find these as well as further information materials both directly in MDA 8 as well as on the ETAS homepage. Thank you for your attention and for your interest in MDA 8.